Guys, you're anxious. Sorry, I need my ears. Boy, guys, you're anxious. Kara, did you get your answer to your question?
Yes, I'm taking another lab class and I just moved, so I'm just confusing everything together. So,
Okay, wait. You're taking another science lab class, not chemistry.
well, this and another one. So I'm
Yeah.
taking 2 science with labs. So, and I just moved, so I just mixed everything together. So I got it all figured out. I'm figuring my life out today.
Did you figure mine out?
I will get there eventually. Let me get to the weekend.
There we go. There we go. Everybody doing okay? Any problems with the safety test or the syllabus test?
No.
Peachy King, everybody get 90s?
Yes.
Melody, you're not putting thumbs up. Did you get a 90?
My name's Cassandra, but no.
Cassandra. But
No,
I'm sorry, you're disguised as Melody Engelman.
Yes.
Okay, Cassandra. You're doing this on purpose, so I won't call on you, right?
Yes.
We're doing fine tonight, guys. I'm really good because I ate beforehand. Let's see. I got to just roughly count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 10, 11, 12, 13, 14, 15. 15, I got 13 people here. Okay. Aisha. Yeah, just as I ask. Okay. Veronica.
Here.
Thank you very much. Kara, I see. Devin, very important, Devin. Are you here, Devin? Devin, if you are not here, you're going to get removed from the class. I'll get back to him. Cassandra's here. Madison. I see her. She's hiding. Madison is hiding on me.
I'm here, sorry.
Ramiro. I see you too.
Yeah, I'm here.
Alex. Hatzias. That's the best Spanish I do, guys. Alex, you're there. I see you right in front of me.
He typed in the chat that he's here.
Okay. Can he talk in the regular mic?
He said he's
Teen.
fixing his mic.
Okay. Teen.
Here.
Thank you, Teen. I said it right too, didn't I?
No, but it's all right.
No. I'm sorry. How do you say it?
Tin,
Tin.
like the
Okay.
element.
Okay, I will redo my phonetics. Simic.
Here.
Thank you. How do you say it?
I go by Matt.
How do you say it? Your first
by
name.
Mac. I go by the name Mac.
Mac, thank you very much. That helps things immensely. And I'm glad to see you here because that means I don't withdraw you. Belle, is Belle here?
There was a misunderstanding.
Here.
Yes.
Thank you, Mac. Victoria.
I'm here.
Thank you, Victoria. Brittany, I saw a flash by. Graciele,
I'm here.
thank you very much. And
Thank you.
Brian Valent. I got 2 Brians in here.
Yep, I'm here.
That's not, no, wait, Brian? Oh, I've only got 1, good. I'm sorry, looking at you, Brian, I can only handle 1 of you.
All right.
Okay, everybody's okay. Everybody did okay on the safety stuff, right? Everybody did the pre-lab to this, right? Because guys, if you didn't missed it, you've lost the opportunity. That will be your drop, all right? Finest kind. All right, we're going to get into one of the hardest things it is to make chemistry students understand, and that is chem and physical changes and properties. All right, I just did this kind of a similar lecture yesterday. So I'm going to start with my 1025 chem and physical properties. Guys, is there anybody that is super confused about this? I am hearing crickets, guys. Please, if you're not really understanding this, tell me right now. And
Maybe we can go to the properties. I understand them, but
no, that's fine, Veronica. I'm just trying to find a level ground that we can talk to each other. All right, before I start, would anybody have a major objection to starting this at 7 o'clock? It would get us out of here quicker. Is there anybody that has an objection? Please speak now. My other two evening classes, I have to hold off until 7:30, but this one I don't. I can start it at 7 o'clock. Is that what we want?
yes, I mean, if it's okay with you.
Veronica, just because you said it, you are the deciding vote. You're the only one that said anything, so we are going to say 7 o'clock. All right, 7 o'clock from now on, ladies and gentlemen. All right? All right, we're dealing with four issues. 4 issues in this particular experiment. We're dealing with physical properties, chemical properties, physical changes, and chemical changes. We need to figure out what is going on with all 4 of these. And so when we're dealing with physical properties, we're dealing with characteristics, traits. What makes a substance a substance? Its color, odor, texture, smell. I guess that would be odor, wouldn't it? What it looks like, what its consistency is. A physical property, what it boils at, what its density is. Physical properties are traits of a substance. So they're very, very good for doing one thing especially, and that is identifying what the substance is. If you have a density of a metal that is bronze-like, it has a density of 8.93 and really, really will stretch out to make big wire-like things, chances are you've got copper. If you've got a clear substance that boils at about 80 degrees centigrade, has a density of about 0.79 and tastes real good when you drink it, then you might have ethanol. So these are all physical properties, and what they do is they help to identify what a substance is. Paper. I have paper. Paper has physical properties. As a general rule, it feels fairly smooth. It's flexible. You can tear it. You can fold it. You can mash it up. There's a lot of things you can do with paper. You can even write on it. Physical properties are what makes paper paper. So paper has the ability to fold it. It has that ability. It has a property. All right? The ability of it to be folded is the property. Actually folding it, performing the action, that is the change. I folded the piece of paper. That is a physical change. I took my chemical liquid, boiled it, made it into steam. That is a physical change, taking it from a liquid form into a gas form. So if it changes, that is a physical change. You can boil it, or you can fold it into nice origami. Anything you do to change the general physical appearance of it is likely going to be a physical change. The bottom line is, I fold this paper. Can I still burn it? Paper burns, right? Can I still burn it? Can I, even if it's folded, can I still tear it?
Yes.
Okay, I take a physical change. A physical change involves changing the overall appearance of something, or change, more importantly in chemistry, changing the state of matter, going from solid to liquid to gas, taking a solid, dissolving it. That's generally the areas of physical change that we are going to be concerned with. Now, a chemical property is the ability to change into another substance. Nitroglycerin has the ability to go boom and break up into water and carbon dioxide. It has the ability. We're not saying it's happened yet. And because it hasn't happened yet, it is a property. It is not a change. When it actually does it, then it's the change. If I have a copper pot, copper has the ability to combine with oxygen to tarnish, to create a blue substance on the surface of the copper. It has the property that it can combine with oxygen. Once it's happened, once that copper has turned blue, it's undergone a chemical change. Stop. Guys, are you still with me?
Yes.
I have no idea what that just did. No idea what that just did. Are you still seeing the slideshow?
Yes.
Yes.
That's the important thing.
Yeah.
All right, when we actually involve a chemical change, the original substance has been converted into something else. Now, remember I said that the physical properties identify the substance. So if you've got new substance, you more than likely have new chemical properties. If you changed it in a new substance, the substance is different, so it probably has new properties. Chemical change. Has anybody ever gone over to Florence? Anybody? Not a person? Guys, you need to do more traveling in your lives. In the main piazza of Florence, they have, that's where the Uffizi Museum is. What they have is they have a porchway, a portico, which is basically a long hallway that's outside. Inside that portico, they used to have all these statues. One of the famous one is the rape of the Sabine women. In Florence, they used to have this David, the statue of David, right in front of the town hall. They can't keep them there anymore because what happens is chemical change. Marble is a base. Marble has carbonate in it. Because it's a base, we have all of this acid rain that floats around. So the acid is going to react with the marble and it's going to degrade it. That's why all the statues are now put away behind air contains special humidors in there. The David, you can't get near it anymore. I feel blessed because I was able to go up in the Vatican and actually reach and touch the Pieta that Michelangelo carved. It was absolutely wonderful. You wouldn't dare leave it out now because it would get eaten alive by the acid rain. Chemical change. Steel rusting. Let's think about this. Brian, what's steel look like?
It's smooth and silver.
Is it hard?
It's shiny, silver, dense.
Is it hard? Dense, hard? All right, let's think about rust. Brian?
Brownish, dull, flaky.
Okay, let's think about this. Are the properties of steel and the properties of rust different?
Yes.
So have we changed it from one substance into the other?
Yes.
We have a chemical change. Does that make sense to you all? If you have, Veronica, you have blue jeans. Do you have any bleached blue jeans? Okay. Blue jeans. What are blue jeans' normal color? Hint. It's in the name.
Blue.
Blue, right? Blue jeans are blue. Now, if you drop the bleach on it, what color do the blue jeans turn?
White.
Whitish. Make sense? We had the property, they were blue before, now they're white. Different substance, different chemical change has gone on. Okay, now here's where this differs from yours. And I'm going to have to change to another PowerPoint. Hopefully I can find it. Okay, I've now switched to your PowerPoint. Okay. If something has undergone a chemical change, then the new compounds are going to have different properties than the old compounds. Okay? I have copper chloride. If I have a copper compound that's dissolved in water, okay, let me erase that. Copper chloride, if I look at it, it has blue crystals. Okay? I have a test tube of clear water. I put the copper chloride into the clear water. I have changed the color of the liquid. The color of the liquid is blue. Now, have I undergone a color change? All right, let's think about this. How many of you have ever made cherry Kool-Aid? Kara?
Yes.
Kara, you've made cherry Kool-Aid? All right, it starts out red powder, right, Kara? Red powder?
Absolutely.
You throw it into the water, and what's the color of the solution?
Red.
Now, Kara, if you take all that water that's in there and you evaporate it away, what do you think you're going to be left with?
Well, either red residue or nothing.
You will end up with red residue. Okay? So, literally speaking, have you changed the Kool-Aid?
No.
You haven't changed the Kool-Aid, so it's a physical change. I'm taking my copper chloride, blue crystals, putting them into water. It may look like you've changed the color of the water, but you haven't really. All you're doing is you're seeing the color of the copper that's in there. So it's not really a color change. The color is from the blue crystals. That is a physical change. If we evaporate all the water off, we're going to get those crystals back. Okay. Riddle me this. I have a clear solution. Victoria, you out there, Victoria?
I'm here.
Victoria, you have a clear solution of potassium thiocyanate, KSCN, that's what that is. You mix that with a clear solution of iron nitrate, FeNO3 taken 3 times. Clear solutions, both of them are clear solutions. You mix them, you get a blood red color. Is this a chemical change, Victoria?
Yes.
The properties were, both of them were clear, right?
Yes.
Now we have a new color. Let me give you another example. You have lead nitrate, PbNO3 taken twice. You mix that, it's a clear solution. You mix that with a yellow solution of potassium chromate, K2CrO4. You mix the two together, you get a yellow solid. Let's see. Before this had the property, both chemicals, the potassium chromate and the lead nitrate, they both dissolved in water. Now we have a new property. It doesn't dissolve in water. Property change. Have we gotten a new chemical change? That's when you are doing these observations. You got to look into this. Okay. Cobalt compounds. Cobalt, that is a salt. It's mixed with an anion. If it's dissolved in water, it gets a red solution. Okay. I put copper metal into a clear colorless solution. After 20 minutes, the solution has a noticeable pink color. Did a reaction take place? Madison, you out there, Madison?
I'm here.
Okay, Madison. The situation is copper, when it is in ionic form, makes a red solution. Okay? What you did, you put copper metal into a clear colorless solution, and after 20 minutes, the solution has a pink color. Do you think a reaction took place?
Yes.
Why? What do you think happened?
I think it was a chemical change, chemical reaction, because some kind of ions from the
Okay, let me ask you this question, Madison. Let me stop you there for a second. What did you start with?
solid, was it
Solid cobalt, right?
cobalt? Yeah.
What makes the red solution?
The cobalt.
Cobalt what? Solid cobalt doesn't dissolve in the solution. It doesn't dissolve in water.
It was the cobalt ions.
So look at what happened. You have cobalt metal that somehow gets transformed into making cobalt ion. Did we change? Did we change the chemical?
No.
We didn't. We have neutral cobalt. Now we have ionic cobalt.
Ion. Yeah. Yes.
So has it been changed?
Yes.
Was it a chemical change?
No, it was a physical change.
Okay, Madison. Let's think about this again. You just admitted you've changed it from cobalt to a different substance, cobalt ion. Have I changed it into a different substance, Madison?
No.
I've gone from neutral cobalt to cobalt ion. Are they the same?
Yes.
Okay, we're gonna get into your, I'm sure you're gonna get into this during this semester sometime, Madison. Ions differ from neutral metals. Ions have either lost electrons in the case of a metal or gained electrons in the case of a non-metal. They have different properties. The first property that's evident to you is that cobalt ions dissolve in water. Cobalt metal doesn't. So it has different properties. It's a different substance. Okay?
Okay.
Ions are different substances from the metals. Since it's a different substance, we have a chemical change. We good, Madison?
I got it.
Does this make logical sense to you?
It does. Thank you.
All right, 10. 10, you out there?
Yes.
Okay, 10. Do you have any idea what the Statue of Liberty is made out of?
Made out of copper.
What color is copper, 10?
Usually it's like brown or orange.
Brown or orange? What color is the Statue of Liberty?
Right now it's like teal, blue.
Okay. We have a different color. Do we have a different substance?
Yes.
Did a chemical reaction happen?
Yes.
We have a chemical reaction, different properties. Are you getting kind of the gist of what I'm trying to push towards you guys? Cassandra, you're out there, Cassandra.
Yes.
Hi there, where you at? I'm not seeing you.
I'm in my room.
Okay. Cassandra, if you put magnesium, you heat it up, you put magnesium into a flame, you emit a bright light, and if you take the magnesium out,
Professor,
1 second. Is it important to interrupt me? If you're not understanding something, talk to me. Is it CMAC? Okay. Generally, guys, it's not a good idea to break me up when I'm trying to explain something, okay? Please politely wait until after I've finished. I generally try and pause after that, okay? If I don't, then say, rude person, rude person. And I promise to start from after that, all right? We have magnesium, we heated it up. After we take it out of the flame, we look at the very end of the magnesium. There is a very, very fine white powder. Now, Cassandra, do you know what magnesium looks like?
It's like magnesium strips are like silvery-ish and they're thin.
Okay. Do we have different properties of the stuff that's left over?
Yes. It's more of a white ash now.
Okay. Different properties. Did we have a chemical reaction?
Yes.
Another thing, another key. Do you remember I told you there was a bright light emitted?
Because you burned it.
Because we burned it. The bright light was the energy being given off. Generally speaking, whenever you see energy given off like that, you can pretty much be assured that there is a chemical reaction. All right. Thank you, Cassandra.
Mac was saying that his mic and his audio keeps going on and in and out. So
Okay, I'm sorry. That's Mike.
Mac.
Mac.
Yes.
Mac. Thank you. Good enough. Brian, are you out there, Brian?
Yes.
Okay. Did I bother you already, Brian? Yeah, I bothered you already. Let's go with
Okay.
Alex. I know I have no use for you anymore, Brian. Alex.
Yes.
Okay. Was that yes or was that yes?
Both.
Okay. I just want to know we're speaking the same language. We are trying to speak English, right, Alex?
I hope so.
Okay. Have you ever done the classic volcano experiment?
I think when I was like 5.
That's about the right time to start it. What you do is you put baking soda into some sort of a receptacle and you add vinegar to it. Alex, what happens?
It expands and foams.
What do you think? The foam. Do you know what foam is?
Is it like aerated liquid?
It's gases that are trapped within some of the liquid. That's all foam is. Okay? So you have formed a gas.
Yes.
All right? Now, in this big vessel, you've allowed the vinegar to react with the baking soda, foams up, comes back down. Then what you do is you take a lit splint. You put it in the air above the reaction. Flame goes out. If you put a lit splint above vinegar, it has no effect. When you put it above the powder, it has no effect. Have you created something new, Alex?
So if it just formed gas, yes.
That's the first indication. Look, we have baking soda. If you know about baking soda, white powder. No gas there, just white powder. Vinegar is a liquid, an off-colored liquid. Again, no gas. We put the two of them together, we make this big foaming thing, lots of gas coming up. Have we changed the property?
Yes.
Okay, now, the other thing we're gonna do to further test this, we put a lit splint above the reaction, not in the reaction, not down in the liquid. We put it in the air above the liquid and the flame goes out. We put that lit splint above vinegar, it stays lit. When you put it above the baking powder, baking soda, it stays lit. No effect when you put it over the reactants. I hope she answered it. Okay. Is the sheriff outside? Okay, we're safe. So when we put that lit splint above the vinegar and the powder, there's no reaction. We put it above our mixture, it goes out. Anybody have any idea what that gas might have been? Nothing, guys?
Hydrogen?
I mean, it becomes a gas, so it means that it changes.
Nitrogen might have been a guess. Veronica?
Nitrogen?
It might have been a guess, but that's not quite right.
Hydrogen?
How if it was hydrogen and you put a flame on it, it's going to go boom. Have you ever heard about the Hindenburg?
No, but I'd like to know.
It goes boom. Trust me. Don't ever do it.
Got it.
Or if you want to do it, make sure I'm in the next county.
Got it.
Okay.
Is it some kind of sodium gas?
Okay, what do they use to put out fires? What's in fire extinguishers?
Carbon dioxide.
Carbon dioxide. Baking soda is made up of a compound. The compound's formula is NaHCO3. It's very easy to take the CO3 and make it into CO2. CO2 is a very, very stable compound. But again, we have new properties. We have a chemical change. On the other hand, if I take hydrogen peroxide, Hydrogen peroxide is a clear liquid. If I treat it with potassium iodide, a white solid, bubbles form. All right? I light a splint, extinguish it, put it in the atmosphere above that reaction, the flame lights back up again. I light a splint, extinguish it, put it over the peroxide, put it over the powder, nothing appears. Did the clear liquid or white powder have a gas in them? Did the reaction mixture?
Yes.
New property. Did a chemical reaction happen? Okay, now, just for kicks and giggles, what do you think that gas is?
Hydrogen,
Not quite. Give me another guess.
oxygen.
Oxygen. The formula for peroxide is H2O2. When you treat it with potassium iodide, peroxide is not a very stable compound. If you just treat it with potassium iodide, you react the peroxide making water and oxygen. I've already done this one. Be careful when you're dealing with temperatures. Has anybody ever broken a bone or had a very bad sprain? You know, you go into the emergency room, the nurse takes that plastic bag, smacks it together, shakes it around, and then puts it on your leg, and it gets nice and cold, right? Do you know what I'm talking about? Or are there any hunters out there? Nobody hunts? Brian, a big mountain man beard like that, and you don't hunt?
It's on my list. It's on my list.
When you hunt, you have the same kind of packs, only when you smack it, it heats up. It's a hot pack. You guys surely have heard of cold packs or hot packs, right?
Yes.
You got to be careful when we're dealing with temperature, because just the act of dissolving something can make something get hotter. So you got to understand what's going on. You got to understand what's going on with your chemical mixture, what you're doing, whether it's going to be a chemical change or a physical change. Okay, what I'm going to do right now, I've been going on for about what? Just about 20 minutes or so? Hey, I can go on. I've been going on for hours today. Are we pretty much solid? Are we pretty much solid as to what we're doing to identify chemical and or physical changes? We're pretty solid on it. Is there anybody that is still confused about this? The whole process for this experiment, we're going to look at the reactants. We're going to look at the reactants. We're going to write down what the observation of the reactants are. Then we're going to mix them. Then we're going to write down our observations afterwards. If nothing happens, nothing happens. Then we didn't get any kind of change. But if we do get something happening, we got to look there and interpret it and just figure out what's really happening. Okay. So I'm going to go and I'm going to hopefully, and this is your class. Yay. All right. We're going to go into course content. And I'm going to take you to the very, very heart of the tomb. We're going into the treasure room now, guys. Now, you're going to have to look at the videos. Dr. Musgrave made the videos. He goes and he explains what's happening in each reaction. So you can see what's happening beforehand and what's happening afterwards. After you are done with that, you're going to get to go to the results. Before you do that though, it's going to, I don't want to do that. Before you go to the actual quiz for results, I want you to go and hook up this link because I'm sure you guys are not super up on double displacement reactions. Double displacement reactions, all right. The best way to describe it, the way to describe it so that you will all remember it. Does anybody know what a key party is?
No.
All right. You go as a couple to this house. The guy of the couple puts the keys into this big bowl. And after all the keys are in the bowl, the women, one by one, go in and reach in and grab the set of keys. Whichever set of keys they grab, that's the guy they go with. That is what a key party is. Guys should have grown up in the 70s. You'd know all about these things. So we have a couple. In a double displacement reaction, we have a couple. We have a cation and we have an anion. But we have another couple, a cation and an anion. So Mr. Cation looks over here and sees Miss Anion and says, she looks pretty hot. So I'm going to go and I'm going to attach to her. So my NH4 attaches to my NO3. In the meantime, Mr. Lead says, ooh, there's a hottie over there. I'm going to go grab OH, Miss OH. So PB reacts with OH. If there is a solid that forms, you get a chemical reaction. If no solid forms, no chemical reaction happens. So that's in a nutshell what happens with double displacement reactions. Please go here and look at this. If you had any trouble in intro with chemical reactions, use this video to help yourself. Okay, we're going to go back here. Now we're going to go into the treasury room, the treasure room. The results section. And I'm going to show you everything. Each one of these is a separate reaction that you're going to have to do. Spoiler alert, guys. You may see this again. Nudge, nudge, hint, hint. Final, final. You may see these again. So if we hit start quiz, it likes me because I've been here before. Our first reaction. What was observed during the mixture of magnesium and HCl? Okay? After you mixed them, you're going to have to see whether there was a formation of a gas, whether it permanently changed color, whether the solid changed color, solution was colder, formation of a precipitate, or the solution got warmer. You have choices. Some things, choose everything that is appropriate. Okay, then once you have done that, you look down at the second question. What was the nature of the change? Did you have enough to call it a chemical change, or was it a physical change? Or if nothing happened at all, no reaction. Do I have any questions about this?
How many attempts?
I believe one. That says one attempt. I can answer that question in a second or two for you.
For the ones that have multiple options for the correct ones, do we get partial credit like if we miss one?
Yes. Yes, Madison, you do. Okay. Second question. You're going to be asked about zinc and copper sulfate. This one has fewer choices. But again, if you get something, what it'll do is there are 4 answers that are given, right? Each answer is worth 2.5. If you click it and it's not supposed to be clicked, you get the 2.5 points off. If you don't click it and it should be clicked, you get 2.5 points off. If you click it and it should be there, you get the 2.5 points. So you're going to go through all of the reactions that are in the videos. There's 3, 4. Okay, 4, 5, 6, 7. Okay, 7 reactions. Now, after you do that, you got to pull back. You got to hold back on your chem reaction knowledge. I have magnesium with HCl. I have a neutral metal with an ionic compound. Does anybody remember what type of reaction this is? Oh, dear God, Mr. Popovich, you're asking me something from 4 months ago? Oh, my head hurts. Come on, neutral substance with an ionic one. It's called a single replacement. When you have a single replacement, if the reaction goes, then what happens is the neutral metal replaces the cation of the other substance. So the neutral metal will push out hydrogen and stick it with chlorine. Anybody remember the Flintstones?
Yes.
What were the main characters? And I do not want to hear Bam Bam and Pebbles.
Fred.
Fred?
Barney.
Barney?
Wilma.
Wilma? Ah, it's that
Betty.
last. Betty, thank you. All right. Fred is looking here. Fred is magnesium. Fred is seeing Barney and Betty together. He likes brunettes. I think I want that. So what Fred does, he's a bigger guy. He shoves Barney off to the side and takes charge of Betty. So Fred links up with Betty. Magnesium links up with chlorine. Poor Barney. Poor Barney's left all alone. It's a sad situation. The main thing about this particular reaction is you have to realize that hydrogen is a diatomic molecule. Hydrogen does not exist as just H. Hydrogen has to exist as H2. Anybody got if you got a piece of paper and a pencil, write this down. Have no fear of ice cold beer. Have no fear of ice cold beer. Have hydrogen, no nitrogen, fear fluorine, of oxygen, ice, iodine, cold chlorine, beer bromine. Those are the 7 diatomic elements. They do not exist as the atom itself. If the atom is by itself, it looks to find another one of its kind to make a diatomic molecule. So when you're going,
Can you repeat the first 2?
hydrogen, nitrogen.
Okay.
If you don't like that, all you got to do is look at a periodic table. Go from nitrogen over to fluorine, down to iodine. That is where the diatomics are. You got to add hydrogen to that, but at least will have gotten 6 of them. So if hydrogen can't be by itself, it is as a compound, H2. Second compound, again, I have a metal and an ionic compound. I had a metal and an ionic compound here. This was a single reaction, single replacement reaction. What do you suppose this is? Same thing. Same thing. Only in this case, we have Mr. Zinc looking to kick out copper. If it does, I make the compound zinc sulfate with copper left by itself. Okay. Do I have a single replacement reaction now? Do I have a neutral metal?
No, it's a the one that you showed us double displacement.
Okay. I have HCl, which is an ionic compound. I have copper sulfate, which is another ionic compound. When you have 2 ionic compounds that are mixed, that has the possibility of being a double replacement reaction. That's how you recognize double replacement reactions. Hydrogen looks to go over and slip in as with the SO4. Copper looks to slip in with the Cl. If you recognize this as HCO3 being the anion, then we have another ionic compound mixed with another ionic compound. Again, double replacement. Recognize it because I have 2 ionic compounds mixed with one another. What do you think this is? Let me see who I haven't bothered. What? Go ahead.
Double displacement.
I have this is an ionic compound. This is an ionic compound. Again, we're going to have a double displacement. What about this one?
That is a single.
I've got a neutral metal mixed with an ionic compound, single replacement. Guys, you're going to have to, sometime during the semester, you're going to have a chapter on chemical reactions. Sometime. This is what we're dealing with when we're dealing with chemical reaction. It's recognition of what we have to be able to predict what the products are. Somebody other than Veronica. You've been doing good, Veronica. This compound, NaHCO3 plus HCl.
Double displacement.
Double displacement. But we have a trick going on here. All right. I do the double displacement, I get NaCl. That seems fairly obvious, right, guys? The other thing I get is H2CO3. Now, can you, from H2CO3, can you see 2 very, very stable molecules? One you deal with every day. One you may use to fill up your coffee pot.
H2O, water.
Look, if I've got H2CO3 and I take those 2 hydrogens, combine them with one of the oxygens, don't I have H2O?
Yes.
What's left? H2CO3, I take away H2O. What is left?
Carbon.
Carbon and
Like,
Chloride.
Ah,
Dioxide.
we're thinking, guys, H2CO3. Okay? I take the H2 away. There's no longer that. So I'm left with CO3. In order to take the H2 away, I have to take away one of the oxygens. What's left?
Carbon
CO2.
Carbon dioxide. So H2CO3 can form two very, very stable compounds, and it'll do it. So yes, it is a double displacement. The Na reacts with the Cl, and the H reacts with the HCO3 to make H2CO3, but that H2CO3 decomposes down to water and carbon dioxide. By the way, ladies and gentlemen, this is similar to the volcano experiment. All right. This is my reaction. I have ammonium chloride plus water. What do you think I'm doing here? Remember, all we're doing is mixing things together, right? We're taking our reactions and we're mixing them, right?
yes.
So what happens when you mix a salt in water?
It becomes not I don't want to say it.
It dissolves.
It dissolves.
It dissolves, yeah.
Yes, it dissolves. All right. If I'm taking ammonium chloride with water and I'm just dissolving it, is that a chemical reaction?
No.
No, it's a physical
Physical.
change. We're changing its state. We're changing it from a solid to being dissolved. Okay, just as a general, for my class I'm giving tomorrow morning, that's, by the way, that's the last reaction. Did this help you? Can you imagine doing this without this talk? All right, I'll open myself to questions. Guys, I've been talking for about 50 minutes now. I'll open myself to any questions you have. I have shown you this is the quiz you have to take for this particular experiment.
Oh,
Look at your results. Guys, this is going to be graded. This is going to be graded by machine. The computer's going to do the grading for this. I'm warning you right now. Look at the results. If you honestly feel that you were graded unfairly, bring it to my attention. I don't always agree with what he has to say, but you have to bring it to my attention with an explanation. You just don't get a free pass by saying, well, I thought that I saw bubbles in this first one. You got to explain it. Well, when you react magnesium with hydrochloric acid, it's a single replacement reaction. I'm making magnesium chloride and H2. H2 is a gas, so I damn well should have bubbles. Are you understanding what I'm telling you to do if you want to question any of the grades?
yes.
Yes, but there seems there's a student, Aisa, asked, with two ionic compounds are mixed, is it a double replacement? And if so, what is the difference with a double displacement?
Absolutely nothing. Semantics. You want to call it double displacement, or you want to call it double replacement, Kara? Kara, do you want to call it, do you really, really, really want to call it double replacement?
I mean, it can.
Kara, you have now been, you can now call it double replacement. I give you permission. Okay?
Oh, yeah, that's fine.
It's the same thing.
But
Double
one of the,
repla-
okay, it's one of the same. Okay.
It's a, what am I trying to think? Guys, help me out here. I'm an English major. What is it when one word means the same thing as another?
Synonym.
Yeah, one of those things.
I think that's what it is.
You can tell I'm an English major, right? I had a 4.0. Well, not a 4, I had a 3.6. Never mind. You got anything else for me, guys?
I have a question for, I don't know if you're gonna go through it for the post lab and the other thing that we have to do.
The post lab for this, Veronica?
Yeah.
I don't mind going through it.
No, but is it like the same thing? Is it a quiz like that?
Hey, guys, it's the first one. I don't mind going through it.
Right, but is the post lab basically the results quiz?
No, the results
Okay.
quiz was the thing I just showed you.
Okay.
Okay? The post labs is what I'm going to be showing you right now. And I'm assuming it's going to be something similar. Start the quiz. Okay. Again, post labs test you, they're word problems that test you on the theory we went through in the experiment. Mothballs gradually vaporize in a closet. Is that a physical or a chemical change?
Chemical.
Physical.
I'm not going to debate the point.
Okay.
All I'm doing is showing you what they are. I'm not going to answer them for you. Hydrochloric acid etches calibration marks onto a piece of glassware. Baking soda fizzes when mixed with vinegar. A rubber band is stretched. Sugar is dissolved in hot coffee. These are hard today. Guys, I don't know. I don't know if I can, these are so hard. I don't know whether I can release them to you. I think, I think you're up to the challenge.
Okay.
Anything else, ladies and gentlemen?
I have 2 questions about the lab report itself.
Everything is online, Madison. Okay?
No, I know. I know that you like to take points off, so I just wanted to clarify something. Don't have
It's my
points
goal.
taken off.
It's what I live for.
Just for so I was going through the actual manual, and I know there's a data table that you want us to put in. My first question is, I know you said that we could have like printed it out and cut it out and glue it in our books. Can we write the table in?
Yes.
Okay.
Yes, certainly.
My next question was, so there was 3 columns, and I just wanted to make sure like what you specifically wanted in each column. One of them was appearance of.
Let me just explain to everybody else, Madison. Madison is talking about the notebook. Remember, guys, you also have to do a lab notebook that I've already shown you an exemplar and explain what I want for that notebook. Now, Madison is describing the data table. So, crap. I got to get out of here and get back in. For some reason or other, it flips me out of there every now and again.
So just to make sure, those are part of the videos or no?
Those are what?
part of the videos,
What is part of the video, Veronica?
like the
The lab notebook.
Lab
Yeah.
note? Okay. Okay,
You
I will go through it again. Or I will go through where it's supposed to be. Okay, go to course content. All right, I'm not going to actually go through the actual notebook again. I'm going to show you where the things are.
Oh, what we want to know is basically with the lab notebook, I know it's based on the lab manual, but do you need us to watch that video from Dr. Musgrove in conjunction with the lab manual when we're filling out our notebooks?
It wouldn't hurt. It will
Okay, so-
it will give you a different perspective, but realize, Kara, that I have it organized the way I want it to be.
That's okay. So for the notebook, just everything really comes out of that lab manual.
Yes.
Perfect. Thank
I
you.
forget, where did I put it?
Oh, I know where it's at online.
try
The
the
lab manual tab right there.
Manual tab? I don't think it's there, no.
Well, what are you looking for?
I'm looking for the power. I know I uploaded a PowerPoint and a PowerPoint and an exemplar notebook. I just can't remember where the hell I put them.
I think that's an instructor notes or something
Where's
towards
instructor
the
notes?
bottom. Yeah, I think yours is.
Ah, yeah, there we go.
Yeah.
Thank you. I was looking for that. Thank you very much. Okay, if you go there, there it is. The lab book notebook is the PowerPoint I gave you last week. The exemplar notebook is an example of a decent notebook. Okay. Now, getting back to you, Madison, I haven't forgotten you yet.
Okay.
All right. So I'm going to pull up the lab manual. And this is going to call up the whole thing, and it's going to take next to forever to load. Thank God, Madison, it's the first experiment.
Thank God.
All right.
No, you went too much down.
It's like one of the first few pages.
I got too far down.
Yeah. It's actually the first page. That's what started.
How did I get that far down?
I don't know. It's page number 5. If you
There
want
it
to
is.
Yeah.
Okay, Madison, this is the 3-column thing you're talking about?
Yes, so I just want to make sure that I understand exactly what goes in each column. So for appearance of reactants, are we just writing down like how?
What they look like.
Okay, so just, all right. The
Then-
observation. Oh, go ahead.
Then what you're going to do is you're going to mix the reactants together.
Okay.
The observations are what happens after you mix them.
Okay, so anything that we see that changes. Okay. And then the type, is that just physical or chemical?
Yes.
Okay, that's all I need.
Sorry, I still don't understand. How are we gonna mix things? I don't have anything to mix.
Oh,
I have-
you're not going
Has
to
to read
mix.
from the manual.
Okay. You're not going to mix. What you're going to do is you are going to
video.
go to the videos. And if this ever loads. Okay, table of contents. Go down to the first experiment, chemical and physical changes and properties. And what you're going to go in here is you're going to look in here. There's a video for chemical and physical changes.
I thought the video that was for the results question.
That's what we're talking about. That's
The
Veronica.
results quiz is based off of the reactions that we're doing in the experiment, which is in the video.
Okay. All right. It makes sense now. Okay. Sorry.
Sorry.
Little slow.
No, it's okay. I was
Okay.
confused too.
So basically what he does is he shows you, literally shows you what does the magnesium look like. You have, he puts it into the test tube and then he squirts the hydrochloric acid on top. That's chemistry talk. Yeah, guys, don't spill it. It could burn you. Okay, woo.
I can't see real closely, but would you consider that bubbles?
Oh yeah. Look
Okay.
carefully. If you look carefully, you'll actually find that the bubbles form on the metal surface itself, and then you get enough pressure in that bubble, they go to the surface and release. Guys, this is what we have to work with.
Okay.
Could be worse. I almost guarantee you that almost all of the other labs are going to be not video produced, but they will be data produced. In other words, there's going to be a data table that you're going to have with your data that you're going to have to do your calculations from. Most every other lab that we're doing this semester is going to be like that.
Okay.
Any other questions?
Nope.
I got nothing more, guys. Hope it was helpful. Believe me, we are going to get through this semester together. I'm going to pull as many people as I can, kicking and screaming, through the travails of Chemistry 1 lab. We'll get you through it, all right? Madison, did you have your question answered about the notebook?
I did, thank you.
There we go. Okay, guys, if that's all, unless you want to sit and watch me watching a computer screen the rest of the evening, and if so, then you have more boring lives than I do.
Just really quick,
Yeah, I'm here.
chemical changes are permanent and physical ones can be reversed. That's right.
Okay, let me give you a caveat with it. You're right, but let me give you a caveat. Chemical reactions can be reversed by chemical means. They're not permanent. They can be reversed, but it has to be through chemical means. Have you ever had to recharge your battery?
Yeah.
All right. What happens when you recharge your battery? What they do at the auto shop is they force the electrical current to go backwards. When they force the electrical current to go backwards, all the lead that's been plated out in your battery then becomes redissolved. And that makes the battery good. Eventually what happens is the whole thing gets so bad, so out of whack, that your battery eventually does go bad, but you can recharge it every now and again. Does that seem to make sense to you?
Yeah.
But, oh, cute guy. Madison, you have a golden?
Yes, my baby. He's been bothering me this whole
Ah.
class for attention.
He looks, I'm sorry, he looks like he's about 3 or 4.
He's a year and 6 months. He's still a baby.
Yeah, Madison, Madison, you got 5.5 more years before he grows out of puppyhood.
Oh, yeah, I've been told that. He still got puppy brain.
I raised 3 of them. I'm sorry. Hey guys, I told you, I get distracted by dogs, travel, and baseball. Somebody was asking a question. I'm sorry that I was rude and went off. Was about chem and physical properties.
No, you answered my question.
All right, good enough. I hope I wasn't rude, and I hope I answered the question before I was rude. Sorry.
You're fine. You did.
Anything else, guys? Madison, I want to see that baby someday.
I sent you a picture in the syllabus quiz or safety quiz.
Good, good. I hope you all sent me similar pictures. All right, guys, if that's it, I got nothing more to say.
Thank you. Have a good night.
Have a good night, guys. You see,
Just like,
that's my hint, guys. When I say something like that, that's my hint for you to get the hell off this Zoom.
last question. For that quiz that we had to send the picture, it says that you grade it.
Yeah, I have to grade that yet.
Okay.
I haven't done it yet. I will grade it. I am starting my second quiz for my intro chem lab in HCC. Give me a break, Veronica. When was it due? Veronica, when was it due?
Oh, I don't remember. I did it the day.
It was due last midnight.
Last minute.
All right, so you've in effect given me 20 hours to grade it.
So I was just asking because I didn't look at the video of the submitting the picture. I basically copy and paste the picture and it looked through it.
Veronica, what happens if you didn't do it correctly? What I'll do is I'll put you in touch with another one of the students that did do it correctly that's willing to help you.
Okay.
I'll be perfectly honest with you. It is really better that they help you rather than me. All right. I'll be perfectly honest with you. Sometimes you got to look at your capabilities. Dirty Harry said it best. A man's got to know his limitations. My limitations are my abilities with a computer.
Okay. I mean, it looks like it works just fine. You showed us a video, you give the class through here, so.
We'll see what happens. Okay, Veronica?
Okay.
All right, guys. And if there's nothing else, I will see you either tomorrow or I will see you next Wednesday.
Have a good night.
Have a good night. Oh, that's why it's not going out.